Yeah, the rational functions. So I think it was. I was like, I was super pumped, man, because I saw what do you call it? Freaking saw a video on what do you? Oh my god, I can't draw. I saw a video on like a sigma notation. I was like, holy flip, what the heck is that? It looks so weird. I've seen it before though, and I still can't. I mean, no, I don't know what this thing is. I don't know what it. I mean, I know what it does. It just like, it's like, it's adding, but just a lot. It's just adding, but more. So it's like, I think how it works is like apparently that's our index and that's our first value. So we're right like I equals 1. We'll start at the first value and then we'll go to our last number will be like 7, and then it's like 4 n. Yeah, we'll do like 4 to the power of n, which this means that we gotta do 4 to the power of 1 plus 4 to the that, and then 4 to the third, and then dot 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 plus 4 to the 7th power, and then you add all these up, and that's your answer. Summation, I think, is what it's called. Pretty sick. I gotta appreciate it. It seems pretty cool. I'm not sure how that could get more complicated, but I've seen it in more like things that look more complicated. So this thing probably is more complicated than I think it would be. Like, let's see here. Let's take a look at this thing. I mean, not this thing. Absolute values. Actually, nah. I don't even want to look at that. I'm not great with absolute values for some reason. I'm not sure why. They just get me good. They punch me good. I tried coming up with the formula with that. Oh, well, like the integration of like the power rule, right? So we got like n x n minus 1. I forgot about it. So I was like, all right, so we need this n to go away, right? So the only way to do that is we just divide by n, right? Duh. Then like, whoop, these go bye-bye. And I was like, to be honest, I wasn't sure how to deal with this. What was I going to do with that? So I was like, okay, we're just going to times by x, right? Because, well, now that is just, that just doesn't matter. But I don't think it works like that. I don't think it works like that. Anyways, that's wrong. I don't know why, but that's all right. Apparently, it's actually this. So we have the integral. I think that means indefinite integral, I believe. X to the nth power dx. I don't know why the dx is here. I don't know. I would assume it's because like, oh yeah, this guy right here, the integral, he's canceling this guy. He's getting him out of here. He's getting them all out of here. And then like, so the integral of x to the power of n is equal to x n plus 1 over n plus 1. And then there's the plus c, which I like, what? Like, I don't know what that thing does. I don't know why he's there. I don't know who he is. I've looked at a lot of math memes, and people talk about forgetting about this guy. I don't know why. He seems real important, though. Plus c. I'll try to remember that when I take the calculus class next year, too, in my school. So, why does this work? I don't know. I just know it does. It's like, what, like, why the plus 1? Why? And I think this doesn't work if x equals -1. Like, x can't equal -1, I'm pretty sure. I don't remember. But, yeah. And integrals are pretty cool. I was always interested in them when I like, wasn't like super a math enjoyer and whatever. We're gonna keep doing this. So we got d over dx, x squared, parentheses again, 2x to the 3rd power plus 1 to the 10th power, and parentheses. Very cool. All right. So you know what, we're gonna very cool. All right. So you know what, we're gonna actually, no, I'm not gonna make it small. I'll just write smaller. And so we have to use the product rule. And let's write this down real quick. We got product rule. I'm just writing these off my my sketchbook. Yeah, so we have a product rule, which means the d over dx, or the derivative. I would assume that's what that means, right? Sure hope that's what that means. D over dx of f of x times g of x. Booyah. This equals this right there. This thing, my bob, right here, is equal to f prime of x, which would be the derivative of f of x. Can I read? I can read. Times g of x, not g prime of x, just g of x. And then plus f of x, normal f of x. And then times g prime of x. So this guy right here, this is our product rule, and it's needed to solve this guy. So we're gonna hit Control C, Control V, copy this guy down here, and boop. Sick. He's here with us now. He looks a little crumpled. That's all right though. I think I got this from like the 100 derivatives video from BPRP. Yeah. Okay. So let's take a look. So this is where we're multiplying, because we're multiplying the x squared plus this thingamabob right here. And you know what? The way I like to do it, or the way I was taught it actually, is, you know, let's just sort it out. Now let's make this look real nice and neat. And you know, we'll figure out which is which. Booyah. So our f of x, we're gonna say this is our f of x. X squared. Very cool. Our g of x, we're gonna say it's that, you know, parentheses 2x cubed plus 1 plus 1 to the 10th power. Pretty simple. This is pretty simple. You just move that 2 in front of the x, right? And you minus by 1, which gives us 2x. Very cool for the f prime of x. This one right here, this is a composite function, so we have like a function, right? So we have like a function, yeah, we have like a function inside of a function. I don't even know if that's how you write that actually. That could be very wrong. We're gonna write it like this then, x, whatever, however you do that notation, or whatever you call that. So we are gonna do the chain rule. We're just gonna, I mean, I guess I could write it out, but I'm just gonna do it the quicker way, I guess. I don't really know what to call it. It's just a way to do it. Look at that circle. That was good. So we're gonna take this 10, plop it down in the front. So we got 10 to the 10, starting parentheses, 2x cubed plus 1. And then we minus the exponent over here by 1, so we get 9. And because this is a composite function, we also have to have the derivative of whatever's inside. So we're gonna times all this stuff right here, right? We're gonna times all that by the derivative of this. So we have our 3 here, right? Here, I'm gonna do this in a different class just so it's easy to see. We have a 3 here, right? We're gonna drag this down in front of this 2, so we have that 3 times 2. 3 times 2 is 6. Very cool. And we're gonna minus 1. So we have we have that 6x here. And now we minus that exponent by 1, which gives us 6x squared. 1 is just a constant, so you know that's just 0. Write that down if you want, I guess, but I don't want to do that. Alrighty, that should be right. Yeah, I'm looking at my paper real quick. That's looking pretty good. That's looking pretty good. All right. Product rule. Let's get this going. Yeah, I kind of need this. Actually, you know what? Nah, we'll do this blindfolded. We don't need that. Yeah, let's how do we do this? All right, you know what? Let's do it like this. So we have our f prime of x, right? So we got that's a horrible f prime of x times our g of x So we have just 2x plus, that's not a plus, it's just a cubed root or whatever, not root, whatever. Yeah, you get it. You know what's up. You're smart. You're a smart guy. You're a smart guy and or gal, whoever you are. Plus, and then we have our f of x. All right, just like our normal f of x. Doop. Times our g prime of x, which is just 10. You know, you're right. Doop, boop, boop, doop, boop, doop. Oh, yeah. Boom, boom. And then, times 6 x squared. I hope that's right. And it looks good from the paper I'm looking at. So we're just gonna scrunch this down a little bit because I can't see. Well, it's not like I can't see, it's just, you know, kind of in the way. We'll make this guy a little smaller too. It kind of looks funny when it's squished like that. Okay. Yeah, it looks a little crunchy. Oh well, we're gonna have to deal with it. So, I can see here. Yep, yeah, it's all working. So I can see here that we have, you know, the 6x. We can just probably times that over here, right? I would assume so, right? Let me look at my paper real quick. That's kind of weird. My paper says that my sketchbook says that this is 60x, but you know, there's the 2 there. So I'm pretty sure this is 60x squared times x squared, which this just gives us 60x quartic to the quarter power. Is that even a word? The quartic power? Is that even how you'd use that word? I don't know. Just taking a look right here real quick, just in case I'm not doing this wrong. Oh, wait. Why did I add that? That's kind of weird. So yeah, we times this 6x squared to that to give us 60, and then we times this to give us the 60x to the square, not the square root, what the flip? 60x. Power 4. So these guys are gonna go bye-bye. These guys are gonna go bye-bye too, I would propose. And, you know, we have this plus 1, 9, plus 2x cubed plus 1 to the 10th power. And from what I remember from the video, we're supposed to factor here because we have that and we got that. Those two are similar. And I'm pretty sure we could factor like a 2x out of this, right? Right? Yeah. Right. So yeah, like, we're going to factor out a 2x and 2x cubed plus 1 to the 9th. So then this goes bye-bye, I think, because that just becomes a 1. And then we have one of those left. Oh, wait. Yeah. Because this just becomes a 1 because, you know, 9 minus 9 is 0. Anything to the 0th power is just 1. So, like, anything to the 0th power is just going to equal 1, right? Yeah, makes sense. The 0 to the 0 power equal 1. Yeah, whatever. That's none of our business. And so, this 2x is going to make that 30, right? 30x cubed. And then, because we only have one of these, it's just going to become this, right? Am I low-key crazy? And then we just, hold on, am I like, I don't know if I'm crazy. Like, again, you gotta remember, I'm not like good at math or anything, you know. I'm just casual. I'm a casual guy. No, that sounds stupid. That sounds stupid, but you know, it's kind of casual about it. And then it's like 32x cubed plus 1. I mean, that's what my sketchbook says. So, yeah, that's our final answer, dude. That's money.